This is 2N5 storage video lecture by Mr. Westfall. Here are your directions and the lesson objective. You're going to open your OneNote class notebook, create a new page in your Unit 2 hardware folder. You're going to name it 2.N5 storage. And when prompted, you're going to copy the notes from this video into the new page of notes that you've just created. The objectives of the lesson, you're going to be able to explain the pros and cons of storage. You'll be able to identify different storage devices and explain the differences between them. Recall from the last lecture that RAM is the main memory of our computer. When you open an application, create a document, or edit a photo on your computer, RAM gets used by the computer to temporarily store data while the computer is working on it. RAM stands for Random Access Memory. The data stored in RAM can be accessed almost instantly, regardless of where it is in memory, so it's very fast. RAM has a very fast path to the computer CPU, or the central processing unit, which is the brain of the computer, which does most of the work. RAM is volatile, meaning that the information that's put in there disappears when the computer is powered off. And this is because RAM uses integrated circuits made of millions of transistors and capacitors that need to be refreshed with electrical energy in order to work. This is a problem because some of the data that we're working with needs to be saved permanently, and this is where data storage steps in. Now I'm going to explain storage. Computers need some form of permanent or non-volatile storage. Here is your definition for non-volatile storage. This is a place to permanently put data where the data remains even when the computer is powered off. And this is the opposite of volatile storage. Non-volatile storage provides a space or place that can be used to store applications, documents, and other data. So your pictures, your music, your PDFs, your videos, and stuff like that. And it's also where the files and data that are associated with your operating system are found. So your Microsoft Windows, if you're using a Windows PC, those files are also stored in a form of non-volatile storage. Non-volatile storage comes in the form of a storage device. A storage device is the computer hardware that writes to and reads from storage. Writing is the process of transferring data from memory to a storage device. Reading is the process of transferring these items from storage into memory. Storage devices for the vast majority of computers used today consist of one or more of the following devices: the hard disk drive, or HDD, the solid state drive, or SSD, or the optical disk drive, or ODD. And I'm going to talk about these three different storage devices in this lecture. The amount of data that a storage device can hold is called its capacity. And at the time of making this video, capacities of storage devices are measured in terms of gigabytes or terabytes. Here's an example of a hard drive that's 2 terabytes in capacity. So it can hold 2 trillion bytes of data. I'm going to start with an explanation of what the hard disk drive, or HDD, is. A hard disk drive, or HDD, is a type of data storage device that is commonly found in modern computers. Internally, it consists of spinning platters, also known as disks, and an actuator arm. And if you guys take a look to the right, there's an image there of a hard drive with the top or the lid removed, and you can see that it has the platters or disks and the actuator arm labeled. A hard drive uses electromagnetism to store the bits, which are the ones and zeros. The actuator arm moves back and forth above the platter and reads and writes the data to the disk. Modern HDDs store billions or trillions of these bits. Obviously, it's measured in either gigabytes or terabytes. And as you guys can see, there are a lot of moving parts with an HDD or hard disk drive.
All right, ladies and gents, I'm going to explain the hard disk drive and some of the pieces and parts inside of the hard disk drive and show you how it works. What I've done is I've removed the screws from the lid. Do not do this at home. If you take the lid off, you're going to introduce dirt and debris and dust into this thing, and it's going to stop working. It even says product warranty is void if any seal or label is removed. So I've broken the warranty. I voided the warranty on my hard drive, but that's okay. This thing didn't work anyways. I've already opened it up in the past as a demonstration of how it works. So once you've taken the lid off, let me explain some of the parts. The thing in the center here is the spindle. Okay, this is what rotates and holds the platter or the disc. Let me see if I can zoom in here. So this particular hard drive only has one platter. I've marked it here with a marker. It's kind of difficult to see, but notice it rotates. So when you boot up a computer, this rotates very fast. And this is measured in rotations per minute. Common RPM rates for modern hard drives are between 5,400 and 7,200 rotations per minute. So this spins around, and as it's spinning, this actuator arm moves back and forth over the surface of the platter. Now it doesn't touch the platter, it basically just hovers over the platter. At the end of the actuator arm is the read-write head. And this is what reads and writes the data to the platter. It does this using electromagnetism. So a hard disk drive uses magnetic properties to store the bits or the ones and zeros. Again, it doesn't touch the surface of the platter, it hovers over it. In fact, the distance between the platter and this read-write head is called the flying height, and it's about 5 nanometers, which is very, very, very small. So again, as the platter is spinning, obviously it's attached to the spindle, it spins around, and as this platter is spinning, the actuator arm moves back and forth, and the read-write head on the end of the actuator arm is what writes and reads the data to that platter. Very cool technology. As you can see though, there's a lot of moving parts, and these things do have issues. One being that they're very slow because there are so many moving parts involved, because it takes a minute for this to spin up and get to speed, and for this actuator arm to move back and forth to find that data. This is kind of a slower technology than what's out there now. So I hope you found this video informative. Let me know if you guys have any questions down below in the comments, and as always, thank you for watching. Make sure you hit that subscribe button. Until then, peace.
A hard drive can either be internal or external storage. The term internal means inside of the computer, whereas external means outside of the computer. And the form factor for hard drives is either 2.5-inch for laptop or 3.5-inch for a desktop or tower. And here are some examples. Here is a 3.5-inch internal hard drive for desktop computers. This is what a 2.5-inch internal hard drive looks like for laptop computers. And then here's an external hard drive. So this connects with a USB cable to either a desktop or a laptop. Modern computers use Sata cables to connect hard drives and other devices to the motherboard. So here's what a Sata cable looks like. Here are the slots on the motherboard that it plugs into, and then it plugs into the Sata hard drive. I'm going to demonstrate in this little video.
I'm going to show you guys how easy it is to attach a Sata hard drive to a motherboard. Looking at the board, we see the Sata ports or Sata slots. This is where our Sata cable plugs into. It's the same on both ends. So we're going to simply plug it in, and there's only one way you can do it because it's got a little notch in the slot and in the cable. Plugs in just like this. Taking a look at the hard drive, the back of the hard drive has a bunch of plugs on it. This one is for the power supply, which we're going to talk about later. This one is for the SATA data cable, which is what we're going to do right now. It simply plugs in like that.
Because they consist of many moving parts, hard disk drives have their woes, and one of these is a head crash. Now, a head crash is the term for when the read-write head on the end of the actuator arm makes contact with the platter. As I showed you earlier, the platters spin, and head crash is basically when the read-write head on the end of the actuator arm touches that spinning platter or disk. This damages the platter and renders the data on the hard disk drive useless. The common cause of a head crash is when the computer is dropped, bumped, slammed, or punched. So don't do that. Because of the shortcomings and weaknesses of hard disk drives, computer engineers have come up with a solution to this. And that's called the solid state drive, which I'm going to talk about next. The solid state drive, or SSD. A solid state drive, or SSD, is a type of hard drive where data is stored in microchips. SSDs are another form of non-volatile storage. They do not have a platter or read-write head or any of the other internally moving parts that are found inside of a traditional hard disk drive. They do not use magnetic storage. Instead, the data is stored on microchips. And because of this, they are way more durable than a hard disk drive and do not succumb to the same fate as a hard disk drive if dropped. So they are not susceptible to the dreaded head crash like the hard disk drive is. And lastly, they are faster than hard disk drives. They have faster access times, meaning that they are able to read and write the data faster. And this is because they are less mechanical than a hard disk drive and there are no moving parts inside. Solid-state drives are found in modern phones, laptops, game consoles, and other devices that require storage and that need to be portable. And this is because they are faster and more durable than a traditional hard disk drive. So you can store as much as you could on a hard disk drive, but because they are smaller and faster and more durable, they're used in modern electronics. While both basically do the same thing, the solid-state drive is better than the hard disk drive, but costs more. And this is true even if they are the same capacity. And here's an image of the inside of a solid-state drive versus the inside of a hard disk drive. Notice again, inside the solid-state drive, you see a lot of microchips. And inside the hard disk drive, you see all the parts that are internally moving, the platter, the actuator arm, read-write head, all that stuff. And here are the solid-state drive form factors. There's the 2.5-inch solid-state drive, the M-SATA solid-state drive, and then the M.2 solid-state drive. Optical disk drive, or ODD. The last type of storage device that we're going to talk about today is the optical disk drive, or ODD. Inside of the drive, a robotic eye uses laser light to read and write data to a spinning disk. There's all sorts of disks. You have CDs, DVDs, and Blu-rays, or all types of optical disks that go into an optical disk drive. This is removable storage, but it's way slower than a hard disk drive or solid state drive, and the capacities of these optical disks are smaller than a traditional hard drive or solid state drive. And these are being phased out in computers and consoles. I know that my tower at school doesn't have a optical disk drive, my laptop doesn't have one, and I know that some of the newer consoles are doing DLC only, where you're downloading your files or your games onto a solid state drive that's inside of the console. So these optical disk drives are being phased out. Did you know that a physical PS4 or Xbox game is recorded on a Blu-ray disc? These fit up to 50 gigabytes of data on these discs, which is still a lot less than a hard drive or even a cheap flash drive can hold. You can buy a 120 gigabyte flash drive these days for about 20 bucks. So even a flash drive holds a lot more than this disc. And as you should know, the speeds of these drives are really slow because it takes a long time to transfer data from this disk or optical disk drive to the hard drive. And if you've ever installed a game from disk to the hard drive of your console, you know exactly what I'm talking about. Sometimes it takes hours to do this. Summary and questions. So to summarize, memory is used for temporary storage of data and files. Of course, the main memory in computers is RAM, or random access memory. This is a type of volatile memory which provides very fast access to data. Storage is used to store data and files for long-term use. This is non-volatile storage, which means that your files don't go away when the computer is off. Another pro of storage is that it's cheap. So the cost of storage compared to the cost of memory is less expensive, and you get larger capacities with storage than you do memory. One of the cons of storage is that it's way slower than memory. This is because the reach from memory to the CPU is very close, whereas the reach from the storage drive or storage device is farther. And obviously, the hard disk drive is a mechanical device, as is the optical disk drive, so it takes a lot longer for that data to get from that storage device to the CPU. Solid state drive is a little faster, but it's still very slow compared to RAM. And here are your questions. Please make sure to watch until the end of the video. As always, thank you for watching. This is Westfall signing out. Peace out.